So it's LeetCode problem 53. Maximum subarray. Given an integer array nums, find the subarray with the largest sum and return its sum. So basically you have given a array of integer called nums, and our task is to choose a continuous subarray. Find the maximum possible sum of that subarray. So what is meant by continuous subarray? Is a part of the array like this. This is our array 1 2 3 4. Okay, continuous means all elements are next to each in the original order. You cannot skip any element, like 1 2 2 3 4 and 5. This is a continuous subarray. Non-continuous means 1 3 4. This is not continuous subarray. Okay, so maximum possible sum, add all numbers in subarray. This is the sum, maximum possible sums, the largest sums among all continuous subarray. Example, see if I have array this 1 2 -1 and 3. So subarray of this one is 1. First we make subarray. Okay, 1, next 2, next -1 and next 3, next 1 2 1 2 2 -1 2 2 and -1 and -1 and 3 2 -1 3 1 2 -1 3. So sum of 1 is 1, 2 sum is 2, negative sum is -1, 3 sum is 3. Okay, next is 1 plus 2. 1 plus 2 is 3, -1 and 2. 2 and -1 sum is 1, -1 3 sum is 2, 2 -1 3. Yes, I have this miss 1 and 1 2 -1. This sum is 2, this sum is 4, and this sum is 5. So the maximum sum of this all is 5. Okay, 5. Maximum sum is 5. Subarray of this is 1 2 -1 3. Okay, if you have all negative numbers like -2 -1 and -3, so the maximum sum is -1, subarray of 1. So let's understand the problem. If you have example this. Okay, idea is at every index in the array we ask one question. In every index of array we ask one question: should I start a new subarray from here or continue the previous subarray? We always choose the option with larger sum. This idea is called Kadan algorithm. So see, if array -2 1 3 4, we use two variables. One variable is current subarray sum and max sum, maximum sum of so forth. Okay, this example. Okay, we are going to find a maximum subarray using Kadan algorithm. So current is current subarray sum. Current keep track on the sum of the current subarray. Like we are considering at every element, we decide whether to start a new subarray from this element or continues the previous subarray. Current always stores the best sum we can get ending at the current element. So max sum so far. Maxsum keep the track on the largest sum we use seen so far in every array. Every time we update current, we check if current is larger than maxsum. If yes, we update current maxsum. So this is simple. Current means sum of subarray ending here. Maxsum is best sum we have ever found. Let's diagram. Okay. Current at starting is 0, max is we give this value, and min a very small number to handle negative numbers. Okay, first element is -2. Option 1 we start new. -2. Option 2 is continue with previous, means 0 plus -2 is equal to -2. So choose max. Current is equal to -2. So current is equal to -2. Update max. Now we update the max. Here we update max. Max -2. This is case is equal to -2. Okay. First element is -2. Okay. First element is -2. And next second element is -1. Option 1 is start new or continues previous. So option 1 is 1, and option 2 what we do, -2 continue with previous 1 is equal to -1. So max, choose max. Current equal to 1, update maxsum. Now here we update maxsum. -2 into 1 is equal to 1. So third element is 3. Option first is start new, -3, and option 2 is continue previous. 1 plus 3 is equal to -2. Choose max. So current equal to -2. Update maxsum 1, -2 is equal to 1. So fourth element is 4. Option 1 is start with new. 4 or choose continue with previous. If you continue with previous, 4 is equal to 2. Choose max. Current will become 4, and update max sum 1, 4 is equal to 4. So answer is 4. Current always stores sum of the subarray ending at the current element. Maxsum always store the maximum sum we have found so far at each element. We compare starting new with continue. Finally, maxsum gives the maximum subarray sum. So yeah, that's it. If we do try done with another example. Let's take possible numbers. Okay, array is equal to 1, 2, 3, 4. So current and max update at each step. Current is equal to 1, max sum is equal to 1. Now current become 3, maximum also become 3. In 3, current becomes 6, maximum also becomes 6. In 4, current become 10, maximum become 10. So the 10. If we see negative case like this, -5, -2, -8, and -1. First is 5. 5 current is equal to -5. 5 max sum also 5. Wait, write down like this. 5, first is 5 and current. Wait. Okay, first element is 5 and current also 5 and max sum also -5. In next element is 2, so current become -2 and max become -2. 8, so current become -8, max will stay like -2 only, and last number is 1. Current become -1, max sum will become -1, because 2 is what, 5 is less, 2 is greater of 5. Negative case is 2 is greater, 5 is less. Okay, let's write down the code. See, we want maximum number. Okay, in negative case 2 is maximum, max number. -5 is min number. Okay, in negative case, so here we keep 2 only. When it's come 1, we update 1. Let's write on the code. 2 is to largest value sum. So far we just get int max sum equal to int current is equal to 0. We store sum of the current subarray. Okay, now for loop for 0, I is less than nums size I plus. Now here current is equal to max nums of I. Current press nums of I. Here decide start new subarray or continue with previous one. Okay, here we are deciding this, and next is max sum equal to max update maximum sum if current sum is bigger. Okay, now we just return max sum. So the time complexity is big of n and space complexity is big of 1. That's it.